Hey everyone, it's Christian. In previous screencasts, we looked at the suite of tools that make up a pairLab experiment, the first of which is a survey. Now we'll look at the second tool in the suite, checking and cleaning the data. So why do we want to check data? Well, for a number of reasons. Maybe you took your own survey. Now, you definitely want to QA your survey. However, you may not want your responses analyzed along with other participants. Another reason? You forgot to close the survey, and somebody later stumbles upon it and takes it, polluting your results. Sometimes your survey participants are bad at taking it. Maybe they aren't focused or they're distracted, and they give you what looks like random responses. Maybe a survey participant abandoned the survey and didn't give enough meaningful responses. Finally, maybe somebody is gaming your survey so they can skew the results toward a result that they favor. pairLab lets you find these situations so you can decide whether to keep responses for a participant or not. Let's take a look at how we check the data. So in this table, we have several columns. The first is a checkbox, and you use the checkbox to select participants so you can include or exclude them in the results, and we'll take a look at that in a moment. Number is an ordinal number assigned to each participant to help you understand the data. And the same is true for ID, except we're using the end of a unique ID assigned to each participant. With voted on, we have the date and time that participants cast their last vote. And you can use this to maybe find yourself or someone who voted that you want to exclude from the survey. Analyze shows yes with the little green dot and no with a little gray dot to indicate if that participant is included in the results calculation. The Stanley score is the degree of randomness in the participant's vote. Okay, what does that mean? Imagine we're testing 3 ice cream flavors, vanilla, chocolate, and strawberry. And I vote for vanilla over chocolate and chocolate over strawberry. Logically, I should vote for vanilla over strawberry. But what if I don't? Well, the more I vote contrary to other votes, at least logically, the more my results look random. And the Stanley score is a measure of this randomness. Almost everyone will have some measure of randomness in their voting, and it tends to creep up with longer lists of ideas. So when is it too much? Well, there's no hard and fast answer to that. A score below 25 shows green. You can see here's a 20, it's got some green. And that's generally acceptable. And a score between 25 to 34, here's one that's 38, which gets the orange flag, indicates some moderate level of randomness. A score of 35 and over, here we have an 87, and you see the red dot next to the 87, indicates that there's a lot of randomness to the point that it may be unacceptable. You need to decide how much you're willing to tolerate. And by the way, the scale tops out at 100, which resembles perfect randomness. Now, why did I call it the Stanley score? Well, it's an homage to the worst player in Chess Master, which was a chess simulation game back in the day. Chess Master gave you characters of different skill levels to play. At the very top, there was the Grandmaster, and I couldn't be anywhere near a Grandmaster, but he was the top character. And at the very bottom was a monkey named Stanley. Now, it's not that Stanley was bad. He was a chimpanzee. It's just that he just did completely random moves, and you could never really build a strategy around random moves. And I could never beat him because our games always ended up in a draw. So I named that randomness score after Stanley, the chimpanzee in Chess Master. All right, let's move on to flags. Flags are text comments that warn you about problematic responses. We have a couple of them. Do we have any skips in here? We don't. So one you might see is skips. In this particular study, we didn't have any skips. Skips means the participant clicked the I can't decide button too many times in a row. And this indicates that they either struggled to understand how the ideas compare or they tried to game the survey in favor of one idea over another. The responses flag, you can see one right here, indicates there were very few responses for that participant. Now, too few responses may only be a problem when the number of votes doesn't exceed the number of pairs broadly across the survey, and that's something I'll talk about in the results summary screencast. And by the way, also a missing Stanley score, and you can see one here, goes hand in hand with the responses flag. Now, Stanley score, I'm going to scroll to the bottom here. You can see this footnote. Asterisk indicates the analysis is pending. Stanley score and flags are calculated a couple of hours after the participant cast their last vote. And you'll see an asterisk in the Stanley score spot and in the flags spot when that calculation is not yet done. All right. So you've looked over your data and decided which responses you want to exclude, or you've changed your mind and maybe want to include some responses you previously excluded. How do you do that? Well, and I'm going to go to the bottom here just because it's easier to access this button. And I'll do it for the last two. You click the checkbox next to the participant you want to either include or exclude, and it's, looking at the flag. So if the flag is excluded, we're going to flip that to included. If the flag, here, let's do this one too. If the flag says it's included in the analysis, then we're going to flip that to excluded. So whatever we check off, and then we hit this toggle analysis button, this flag will flip to its opposite. So let's do that. I'll click toggle analysis. Let's scroll down, and now you can see yes is now no, and no is now yes. And I'm going to just change that back because this is some real data, not demo data. And there it's back. Okay, good. And of course, when they are excluded from the analysis, their votes will not be calculated in the results. And if they're included, then they will be calculated in the results. And that's checking your data.